US Physics Olympiad, year 2016, F equal MA. First round. For this round, there were 25 problems for 75 minutes. All solutions for these problems you can find in the reference below this video in the description. Problem 1. A car drives counterclockwise around a flat circular curve at constant speed, so that the left front wheel faces out a circular path of radius r equal 9.6 meters. If the width of the car is 1.74 meters, what is the ratio of the angular velocity about its axle of the left front wheel to that of the right front wheel of the car as it moves through the curve? Assume the wheels roll without slipping. Problem number 2. A 3 centimeters thick layer of oil with density ρ0 equal 800 kg per cubic meter is floating above water that has density ρw equal 1000 kg per cubic meter. A solid cylinder is floating so that 1/3 is in the water, 1/3 is in the oil, and 1/3 is in the air. Additional oil is added until the cylinder is floating only in oil. What fraction of the cylinder is in the oil? Problem number 3. An introductory physics student, elated by a first semester grade, celebrates by dropping a textbook from a balcony into a deep layer of soft snow, which is 3 meters below. Upon hitting the snow, the book sinks a further 1 meter into it before coming to a stop. The mass of the book is 5 kg. Assuming a constant retarding force, what is the force from the snow on the book? Problem number 4. A small bit slides from rest along a wire that is shaped like a vertical uniform helix spring. Which graph below shows the magnitude of the acceleration A as a function of time? US Physics Olympiad, year 2016, F equal MA, first round. Problems 5 and 6. The following information applies to questions 5 and 6. Consider a particle in a box where the force of gravity is down as shown in the figure. The particle has an initial velocity as shown, and the box has a constant acceleration to the right. Problem 5. In the frame of the box, which of the following is a possible path followed by the particle? Problem number 6. If the magnitude of the acceleration of the box is chosen correctly, the launched particle will follow a path that returns to the point that it was launched. In the frame of the box, which path is followed by the particle? Problem number 7. A mass on a frictionless table is attached to the midpoint of an originally unstretched spring fixed at the ends. If the mass is displaced a distance a parallel to the table surface but perpendicular to the spring, it exhibits oscillations. The period t of the oscillation behave like these answers. So we need to find what is correct answer. Problem number 8. Kepler's laws state that, first law, the orbits of planets are elliptical with one focus at the Sun. Second law. A line connecting the Sun and the planet sweeps out equal areas in equal times. And the third law. The square period of the planet's orbit is proportional to the cube of its semi-major axis. Which of these laws would remain true if the force of gravity were proportional to 1 over r cubed rather than 1 over r squared? Problem number 9. A small bead is placed on the top of a frictionless glass sphere of diameter d as shown. The bead is given a slight push and starts sliding down along the sphere. Find the speed v of the bead at the point at which the bead leaves the sphere. Problem number 10. Two blocks are suspended by two massless elastic strings to the ceiling as shown in the figure. The masses of the upper and lower block are m1 equal 2 kg and m2 equal 4 kg respectively. If the upper string is suddenly cut just above the top block, what are the accelerations of the two blocks at the moment when the top block begins to fall? Problem number 11. The power output from a certain experimental car designed to be shaped like a cube is proportional to the mass m of the car. The force of air friction on the car is proportional to AV squared, where V is the speed of the car and A the cross-sectional area. On a level surface, the car has the maximum speed V maximum. Assuming that all versions of this design have the same density, then which of the following is true? To which expression V max proportional? US Physics Olympiad year 2016. F equal MA, first round. Solutions for all problems you can find in the reference of the description below this video. If you are not subscribed yet, please do this. Problem number 12. Block floats partially submerged in a container of liquid. When the entire container is accelerated upward, which of the following happens? Assume that both the liquid and the block are incompressible. Problem number 13, not 12. An object of mass m1 initially moving at a speed v0 collides with an originally stationary object of mass m2 equal alpha m1, where alpha less than 1. The collision could be completely elastic, completely inelastic, or partially inelastic. After the collision, the two blocks move at speed v1 and v2. Assume that the collision is one-dimensional and that object 1 cannot pass through object 2. After the collision, the speed ratio r2 equal v2 over v0 of object 2 is bounded by next inequalities. Problems number 14 and 15. The following information applies to questions 14 and 15. A uniform rod of length L lies on a frictionless horizontal surface. One end of the rod is attached to a pivot. An unstretched spring of length L much greater than small l lies on the surface perpendicular to the rod. One end of the spring is attached to the movable end of the rod, and the other end is attached to a fixed post. When the rod is rotated slightly about the pivot, it oscillates at frequency f. Problem number 14. The spring attachment is moved to the midpoint of the rod. and the post is moved so that the spring remains unstretched and perpendicular to the rod. The system is again set into small oscillations. What is the new frequency of the oscillations? Problem number 15. The spring attachment is moved back to the end of the rod. The post is moved so that it is in line with the rod and the pivot, and the spring is unstretched. The post is then moved away from the pivot by an additional amount L. What is the new frequency of oscillation? Problem number 16. A ball rolls from the back of a large truck traveling 10 meters per second to the right. The ball is traveling horizontally at 8 meters per second to the left relative to an observer in the truck. The ball lands on the roadway 1.25 meters below its starting level. How far behind the truck does it land? Problem number 17. As shown in the figure, a ping pong ball with a mass m, with the initial horizontal velocity v and the angular velocity omega, comes into contact with the ground. Friction is not negligible, so both the velocity and the angular velocity of the ping pong ball changes. What is the critical velocity Vc such that the ping pong will stop and remain stopped? Treat the ping pong ball as a hollow sphere. Problem number 18. A spinning object begins from rest and accelerates to an angular velocity of omega equal pi over 15 radians per second, with an angular acceleration of alpha equal pi over 75 radians per second square. It remains spinning at that constant angular velocity and then stops with an angular acceleration of the same magnitude as it previously accelerated. The object made a total of 3 complete rotations during the entire motion. How much time did the motion take? Problem number 19. A semicircular wire of radius r is oriented vertically. A small bit is released from rest at the top of the wire. It slides without friction under the influence of gravity to the bottom, where it then lifts the wire horizontally and falls a distance h to the ground. The bit lands a horizontal distance d away from where it was launched. Which of the following is a correct graph of RH against d square? Problem number 20. A uniform solid right prism whose cross-section is an isosceles right triangle with a height h and the width w equal to h is placed on an incline that has a variable angle with the horizontal theta. What is the minimum coefficient of static friction so that the prism topples before it begins sliding as theta is slowly increased from 0? Problems number 21 and 22. The following information applies to questions 21 and 22. A small ball of mass 3m is at rest on the ground. A second small ball of mass m is positioned above the ground by a vertical massless rod of length L that is also attached to the ball on the ground. The original orientation of the rod is directly vertical, and the top ball is given a small horizontal nudge. There is no friction. Assume that everything happens in a single play. Problem number 21. Determine the horizontal displacement x of the second ball just before it hits the ground. Problem number 22. Determine the speed v of the second originally top ball just before it hits the ground. US Physics Olympiad, year 2016. F equal MA, first round. Problem number 23. A uniform thin circular rubber band of mass big M and the spring constant K has an original radius R. Now it is tossed into the air. Assume it remains circular when stabilized in air and rotates at angular speed omega about its center uniformly. Which of the following gives the new radius of the rubber band? Problem number 24. The moment of inertia of a uniform equilateral triangle with mass M and side length A about an axis through one of its sides and parallel to that side is 1/8 ma square. What is the moment of inertia of a uniform regular hexagon of mass M and side length A about an axis through two opposite vertices? Problem number 25. Three students make measurements of the length of a 1.5 meter rod. Each student reports an uncertainty estimate representing an independent random error applicable to the measurement. Alice. A single measurement using a 2 meter long tape measure to within ± 2 millimeters. Bob. Two measurements using a wooden meter stick, each to within ± 2 millimeters, which he adds together. Christina. Two measurements using a machinist's meter ruler, each to within ± 1 millimeter, which she adds together. The student's teacher prefers measurements that are likely to have less error. Which is the correct order of preference?